function by flipping it, becoming 1 over top. And our x-intercepts, which will be our non-permissible values, are going to be called our horizontal asymptotes. So these are where our restrictions will be on x. So they're going to be represented by a horizontal line on our non-permissible values. So this should actually say -1 here. Again, this should say -1. Non-permissible values. So y equals 0 will be the horizontal line of one of the boundaries of where your graph is going to touch. So the first one we're looking at is, it wants us to determine the equation of the vertical asymptotes of this graph. So the vertical asymptotes are, what can x not be? So what x cannot equal. So if we look in our denominator, you're looking for what x cannot be if that denominator was equal to 0. So you can just set it equal to 0, and you're going to solve for x. So I add 3 to both sides, and then divide by 4. So x equaling to 3 over 4 is going to be one of my vertical asymptotes on my graph. So that means if I were to go onto my graph, and this is the same as 0.75 on the x. So let's say 1, 2, at 0.75 right here, you would have a boundary line. So that's where your graph is not going to cross ever. And then we'll always have our horizontal asymptote. So the horizontal one will be y equaling to 0. So that would be this line here. So now I have these boundaries set up on my graph. So when I go to graph it, the graph is never going to touch those 2 lines. For all of our reciprocal functions, which is 1 over f of x, y cannot be 0, and that's because you can never divide by 0. So this means that our line y equaling to 0 on the x-axis is our horizontal asymptote. And then when we have the function of y equals f of x, this means that if we had another value, we wouldn't be able to have y equaling to 1 or y equaling to -1, which is intersecting. So let me show you how we come up with our asymptotes and then graphing our first example here. So we're not going to be able to have y equals 0, so you can put a dotted line on that asymptote right there. And then to find so that's our horizontal one. To find the vertical one, we go to our denominator, and we're going to set that equal to 0. And to find the vertical asymptote, we solve for x. So I would -3. And then divide by 2. And that's the same as -1.5. So that's the vertical asymptote. So if I go to -1.5, I'm going to put a vertical line down -1.5. I'm going to graph the original graph. So this is my original. And it's in the y equals mx plus b form. So we can see that our y-intercept is 3, and our slope is 2 over 1. So we've done this already in this unit, so we're going to graph this starting at 3. So I'm going to start on my y-intercept at 3, and then I'm going to do my slope 2 over 1. So this is what our original graph looks like when you just graph the line. Now to actually graph your reciprocal function, this is going to look like, you're going to choose this point and you can choose this point here maybe. It's just going to tell you that your graph is going to look like this when you actually graph it as a reciprocal. So if you graph the original, it's going to tell you the quadrants in which you're going to draw these shapes in that graph. So that's what a reciprocal function graph looks like. They're in the opposite quadrants and they kind of look like L's. The original is just telling me exactly what quadrants it's going to be in. So let's try the next example. So again, we're going to have the horizontal asymptote at our y equals 0. Draw that dotted line. And then we'll have the vertical asymptote. And that will be what x can't be from the denominator. So we'll add 4. Divide by -2. So x would be -2 as my vertical one. And then from there, we'll graph the original graph. So looking at our original, which is -2x minus 4, whatever our f of x is in the bottom here, we can tell it's got a slope of -2 over 1, and it's got the y-intercept at -4. So I would start at my -4, and I would go up to over to the left one because it's a negative slope. So it looks something like this as our original. And you can always tell it goes through that x-intercept, which happens to be our axis, or our vertical asymptote, right? So now this tells me it's going to graph, and I'm going to do the actual reciprocal in green. So it'll be in this quadrant and this quadrant down here. Like that. And that's how you graph the reciprocal. So these ones, we're looking at just linear lines, right? So the straight lines. Tomorrow we'll look at what our reciprocals look like for quadratic equations, so parabolas. I'll just do the range and domain just so you're aware of what it is. So your range will be all real numbers, but then you also want to say y cannot equal 0. And then the domain is all real numbers, but x cannot equal -2. So that's the range and domain on that one. Okay, so the last example 3 is we're actually coming up with the equation now for our reciprocal function. So some things you can tell from the graph is you can see that our asymptote is x not being able to equal -0.5. What I'm going to do here is actually draw in the original. So I know there's going to be a point here. I'm going to put a point here, and I'm going to put a point here, and try and draw a straight line as best as I can. So there's my original line. So I'm trying to find points to actually be able to find the slope, because these are all in between the lines. So if we go up 1, 2, 3, 4, 1, 2, 3, 4, and then over 1, 2, 3, 4, I think the slope is 1 over 1. And it looks like our y-intercept is 0.5. So our original line looks like 1x plus 0.5. So then our reciprocal function would be 1 over top of x plus 0.5. And that should make sense, because if you look in your denominator, your x cannot be equal to negative 0.5, because then it would be 0 in the denominator. So that's how we can get what x cannot equal, which makes sense from our graph as well. So plot some points, draw the line, find the slope, the y-intercept, and then put 1 over top of that equation.